And I invite Ayush Prasad to share the screen and tell us more about creating Jupyter-based OpenIFS training material. Ayush, the floor is yours. Thank you.
Yes, so hello everyone. My name is Ayush. I'm a third year computer science undergraduate studying at Sikkim Manipal Institute of Technology in India. My mentors are Olivia, Michael, and Adrian. So my project is about creating a Python interface for the OpenIFS and then using that interface to create training materials for the OpenIFS models. So before moving on to the actual project part, I would like to give you all the brief introduction about what OpenIFS is. OpenIFS is a weather prediction model, which is a more easy to use and uh, more easy to use and slightly uh, easy to operate version of the integrated forecasting system, which is used at ECMWF. It has many of the same capabilities minus the data assimilation capabilities. OpenIFS is predominantly written in Fortran, and it is configured using a set of name lists in which different variables are configured, such as the dates of the model run, input directories, etc. So to currently use OpenIFS, the users have to perform quite a long steps. Some of them are, first step is to install the OpenIFS binary locally. This requires all of the prerequisites to be fulfilled, such as the compilers and the other uh, environment variables and the other APIs to be set up locally. Next, the initial data has to be downloaded, which would be sent to the OpenIFS. This consists of the name lists and the initial conditions. Then if the model's performance has to be evaluated, then we would also need to download the reanalysis data from the ECMWF servers or through any other way. Next step is to configure the working directory. We copy the files which are created in the previous step, and then we place them here on the working directory. And yes, so what I was saying is that why should we create a Python wrapper and use Jupyter notebooks? So main benefit would be to make the process more interactive and easy to use. The third benefit would be it would allow the users to focus more on the actual science behind weather forecasting instead of spending their time in setting up environment variables and downloading data and then linking that. And it would be much more beneficial for everyone if they focus more on the actual science in the initial stages. And finally, it would make it possible to create a containerized access to the OpenIFS. Now, the advantage of this is that we can then deploy these notebooks on any server. For example, as a part of this project, we have planned to test this on the European Weather Cloud, but this could also be expanded to many other such servers. And later on, it could also lead on to the possibility of providing OpenIFS as a service, which that platform could be, which could be beneficial for many other use cases as well. Now, as a now for this project, for one of the first use case is to run the Desmond 2015 Desmond case in the Jupyter Notebook environment. So for doing that, the existing method, like I said, is to first to copy the initial conditions to working directory, setting the environment variables, and then the name lists have to be downloaded and they have to be edited. And as you can see here, these are the different variables. This is the time step of the model, and this is the number of processors used along with other such variables. And then the fourth step is to run the model. Now, as I said, the major disadvantage of this existing method is that in the initial stage, it would require users to switch between many windows, and that would not be a very good use of their time. In the ESoC 11 way, we are proposing and have developed the initial prototype to run the Desmond model through a Python function. Now, as you can see in this Desmond function, we are providing the time step the processors, the number of thread used, and other such variables through a Python function. Underneath this Desmond FC function is the IFS bench package, which is being developed internally at ECMWF. The IFS bench package reads in the name list via the F90 NML package, and then it converts those to usable Python variable types. Then after that, it does not just convert those to Python variables, and it also executes the model, and it also has the capabilities to benchmark the outputs. As a part of this project, we are also expanding this IFS bench package so that it could be used for many other use cases in our project. The next step after the models are run is to visualize the outputs. Now, again, on the left side, you can see the existing method, how the outputs are visualized using Metview. Now, in Metview, the plotting can be done in two ways. The first step is using the interactive tool, which is actually a very good um, way to visualize the outputs. I personally benefited a lot in the initial stages. And the second way is to use the batch mode using the Metview macros. Now, Metview has a programming language, which is a very powerful way to use all the capabilities of Metview, and it provides many other such features. Now, again, the main challenges of using this existing method is that all both of these Metview visualization processes require the the steps to be done in a completely different workflow, which is not very beneficial in the starting stages. And it would be very nice if the person who is learning can simply visualize in the notebook himself. So in the ESOC 11 way, we are again using the Metview Python bindings, which is a relatively new tool which is being developed at ECMWF. Now, Metview Python is built up on top of the Xarray and NumPy and Pandas and many other such Python libraries, and it also adds its own features so that the entire existing Metview can be accessed using a Python interface. Now, using this, the visualization can be done in Jupyter notebooks. This is one of the example plots which we have created using of the Desmond case. This is a temperature plot for the October 15th, and many such plots are available on a Jupyter notebook in the ESOC 11 repository on GitHub. The next step of extending the visualization is to use the Metview macros, which are currently used for comparing the results with the reanalysis data and to convert them to their Python equivalent so that we can also compare the reanalysis data in our Jupyter notebook. So these are the broad next steps which we have to take. First step one is to extend the configuration options. Right now, the configuration options for the using the Python IFS, Python OpenIFS is very limited. We are just able to configure the number of processors, the number of dates, the latitude, longitude, and we would like to extend this to further more configuration so that everything can be done through the Python interface. The next step is, like I said in the previous slide, would be also to translate the existing Metview macros to their Python equivalents, so that the reanalysis data can be visualized in the notebooks. And finally, our major end goal of this project would be to use Jupyter notebooks and deploy them on Jupyter Hub, which would allow everyone to use a single server. And so whenever people in a workshop or anywhere else in the initial stages can simply log on to a server and then run the OpenIFS there itself without having to download anything on their computer, which would, I believe, would be a very helpful step. And we would also like to test this on European Weather Cloud. You can follow our progress on GitHub, and it would be very nice if you all can provide us some suggestions so that the use of usage can be improved for everyone. That's it from my side. Thank you.
Thank you, Ayush, for presenting your exciting project updates.